Hello everyone. Welcome back to our channel, where we explore Zimsec examination practical paper questions in a fun and exciting ways. Today we have some really cool calculations lined up for you. Have you ever wondered how to calculate the area of a brick? Or how much force that brick exerts on a table when placed on different surfaces? Well, you are in the right place. Today, we are going to dive into some fascinating concepts as we discuss a Zimsec June 2020 past examination paper question, which involved those concepts. So get ready to get your calculators. By the end of this video, you all not only know how to calculate area, but also understand the concept of force and how it applies. Enjoy.
In this experiment, I conducted a series of measurements to obtain the relevant data. The results from these measurements will be used to answer questions in Paper 3 of Zimsec June examination of year 2020. I will also discuss how these results can be utilized to answer the subsequent questions, interpreting the data in the context of our experimental objectives. This analysis will help to shed light on key findings and provide insights into the implications of our results. Enjoy and stay tuned. So on the screen are all the questions we are going to look at in this video. We are only going to look at question 2 of Zimsec Paper 3 examination of June 2020. Let's embark on a journey of imagination, where we simulate the anticipation of the projected scene, embrace the reality of what actually transpired, and engage in intriguing discussions and interpretations. It's an experience you cannot miss. Now that you have seen and hopefully understood what was required, I will now display the results I obtained from the brick I measured. However, I will not show the measurement steps. For brick face A, I obtained this for width 10 cm. For the brick face area A, I measured a length of 22.8 cm. For face area B, the width of face area A will now be the length of B, so we only need the height, which will correspond to my width as shown here. Now let's examine the questions, given that we have the necessary results to move forward. The area of brick face labeled A is calculated by multiplying the length by the width. In this case, the length is 22.8 centimeters and the width is 10.0 centimeters, so the area is 228 square centimeters. The area for surface area labeled B is given by the formula length multiplied by width, which is 6.8 centimeters by 10 centimeters, resulting in 68 square centimeters. Completed Table 2.1 will now be displayed along with some further explanations. The areas we calculated are in square centimeters, but in Table 2.1 area results are required in square meters. So, to calculate the area in square meters from centimeters, you need to convert the measurements from centimeters to meters. To convert the dimensions from centimeters to meters, you divide the centimeters by 100 as shown in this table.
Now moving on to recording results in Table 2.1. Make sure to record ruler reading results to 1 decimal place. It was also required to record the readings in meters. To achieve that one, had to know how to convert centimeters to meters. To convert centimeters to meters, you divide the number of centimeters by 100. Weight of brick was also required. Calculating weight involves understanding the relationship between mass and gravitational force. Weight is equal to mass in kilograms multiplied by acceleration due to gravity. Weight is measured in newtons, while mass is measured in kilograms. Acceleration due to gravity is measured in newtons per kilogram. Let's continue as we now look on how pressure varies depending on the surface area labeled A or B on the brick.
Calculating pressure from surface area labeled A, pressure is equal to force divided by surface area of A. Now surface area A has length 22.8 centimeters and width 10 centimeters. Area in square meters is equal to 0.228 multiplied by 0.102 to give 0.0228 square meters. Force in this case is the same as the weight of the brick, which is 3.1 multiplied by the acceleration due to gravity, 10 newtons per kilogram, giving 31 newtons. Now plugging in the values in the formula for pressure, we have 31 divided by 0.0228 square meters to give 136 pascals, repeating the same for surface area B. Check the outlined steps on the screen. Pressure is defined as the force applied per unit area. The force was the same considering the same brick was used. Surface area A was greater, therefore the pressure was less. This is because force is distributed over a larger area, resulting in less pressure. Conversely, looking at surface area B, the pressure increases because the same force is concentrated over a smaller area. Therefore, there is an inverse relationship between pressure and surface area when the force is kept constant. Now moving to question 4. The pressure exerted by the brick with a mass of 6.2 kilograms is approximately twice the pressure exerted by the brick with a mass of 3.1 kilograms. Assuming the area of contact remains the same, which is the case here since the dimensions are the same. Therefore, the effect of doubling the mass, when the mass of the brick is doubled while keeping the same dimensions, and therefore the same contact area, the pressure exerted by the brick also doubles. This is because pressure is directly proportional to the weight of the object, if the area remains constant. The last question required one source of error, however, I will highlight more than one. Surface imperfections. If the surface of the brick or the surface upon which it is placed isn't flat or is covered by something, it can affect how the weight is distributed and therefore the pressure exerted. Variations in brick density or porosity could lead to different weights for seemingly identical bricks, affecting the force applied. If there is an error in measuring the dimensions of the brick to calculate the surface area, it will affect the pressure calculation. If you're looking for more resources to enhance your studies, don't forget to check out the link in the description below. There, you can download the Zimsec Examination Past Examination Paper 3 of Year 2020 Practical for an in-depth review. Thank you for tuning in. We hope you found this review insightful and engaging. If you enjoyed this deep dive into Zimsec practical examination questions and want to boost your learning journey, Don't miss out on hitting that subscribe button. Join our growing community of curious minds, where we unravel the mysteries of science and empower you for exam success. Stay ahead of the curve with more exciting content, tips, and tricks that will make your study sessions a breeze. Remember, every subscription fuels our passion to bring you even more valuable resources. So, what are you waiting for? Subscribe now, and let's conquer those exams together. See you in the next video.